In this tutorial, our focus will be on mastering the creation of tension-only bracing members within space gas. These specialized members are designed to exclusively bear tension loads without being subjected to any compressive forces. It's worth noting that this technique can also be adapted for constructing compression-only members if needed. Let's delve into the process. Let's consider the scenario of a moment frame, as depicted on your screen. Our objective here is to incorporate bracing members strategically. This addition of bracing is intended to effectively mitigate the lateral deflection that arises when a lateral load is imposed upon the structure. In this specific illustration, we will simulate the application of a horizontal load of 50 kN. This force is directed towards the right and is applied at the upper left corner of the frame. To facilitate a clear comparison of the impact of the bracing members, let's create a duplicate of the entire frame. This duplication will enable us to directly observe and assess the effects brought about by the introduction of these bracing members. To start with, maybe we can assign a small equal angle section to these bracing members. We can always go back and change them later if necessary. Moving forward, our objective is to designate the bracing members as tension-only elements. This specific classification ensures that these members are exclusively capable of bearing tension loads and are immune to any compression forces. Let's initiate a nonlinear analysis to obtain results for both the braced and unbraced frames. By displaying the deflection results, we can clearly see that the lateral deflection exhibited by the braced frame is notably 1/10 of that observed in the unbraced frame. This striking reduction in lateral deflection underscores the efficacy of the introduced bracing members in enhancing the structural stiffness and mitigating the extent of displacement under the applied lateral load. You might have also observed the absence of two bracing members from the configuration. This outcome is a direct consequence of their classification as tension-only elements. These members have been automatically excluded from the frame since they are in compression. Next, we want to check the axial stress in the bracing members. Typically, we want to keep the axial stress below the yield stress of the steel. It looks like the bracing members are experiencing quite a high axial stress. We can reduce the stress by choosing a bigger section. Evidently, the utilization of a larger section has led to a significant reduction in stress levels. In the current scenario, the stress magnitude is now merely 1/3 of its previous value. Also, the lateral deflection is further reduced. That's the end of the tutorial. Thank you for watching and I hope you've enjoyed it.